Question 6. 4-nitrobenzoic acid is an important compound in chemical synthesis. The flowchart below shows a synthesis involving 4-nitrobenzoic acid, which is this molecule here. We can see here. So the carboxyl group, this carboxylic acid group here on carbon 1, and nitro on carbon 4. So 4-nitrobenzoic acid. State a suitable reagent, so a suitable reactant and conditions for step 1. So again, look at what's happened. Look how the molecule is changing. The NO2 group is staying the same. All I'm doing now is replacing the hydrogen of the OH group within the carbon chain. So I'm forming here as an ester. So I've got to think from skeletal formula, there's 2 carbons here. So therefore, what was my, and then the O, therefore my alcohol, what will it have been? Well, 2 carbons in a, there's nothing else you can do with it. There's only one possible alcohol with 2 carbons in it and no branches. So I'm going to have ethanol as one of my as a suitable reactant. So I'll put the chemical formula C2H5OH. Okay, and conditions for making an ester. Again, this is a repeat of a question we've had earlier on just with a different alcohol. So conditions: I need an acid catalyst, I need heat, and I need reflux. Okay. Question part 2. Step 2 in the NO2 group in compound F is reduced by tin and concentrated hydrochloric acid. Write an equation for the reduction of compound F. Show the structures of any organic compounds involved. Okay, so that means if you see that, draw out the structures, either displayed, skeletal, whichever one you want to do, but show the structures clearly. So what's happening? So the reaction of nitro group with tin and concentrated hydrochloric acid, what this does is turns a nitro group into an amino group. So NO2 becomes an NH2. Nothing else will change. Nothing else will happen to the molecule other than NO2 becomes NH2. So I take compound F. It should show the structure of any organic compounds involved. So I'll take compound F as you see it. Benzene compound, NO2, and then the ester group. Keep it in the same formula. Don't try and fiddle with it. That way, you less chance to make mistakes. There's compound F. Reacting it then with tin and hydrochloric acid. It's a reduction reaction. So just like with oxidation reactions, we can use a shorthand notation to represent the reducing agent. I don't need to include tin and HCl in essence in the reaction. All I need to do is use H in square brackets. This is a symbol for my reducing agent, like O in square brackets is the symbol for the oxidizing agent. So that's my tin and HCl will produce the organic compound thusly. So nothing's going to happen to my ester group. That's going to stay exactly the same. The NO2 will change to NH2. So logically, think what's happened. What's left out, what's going to be also formed as a result of that is water. So there's the full equation. We now need to balance it out. Okay, now we're thinking about how many hydrogens are present here. I've got 1, 2, 3, 4, 5, 6, 7, 8. And on this side, 1, 2, 3, 4. I need to have 8 in total on both sides. Okay. So actually, no, I don't. I need to balance this a bit better than that, beg my pardon. So think about what I've got. I'm going to have to have 6 of those and 2 waters to balance this equation out. Okay, think about what I've got now: 6, 7, 8, 9, 10, and then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's no other way you can balance it out. That's the answer. 2 marks for that one.